Welcome to my channel. World Scene News. Subscribe to my channel for news updates all around the world. Most of us drive through tunnels without a second thought, but have you ever wondered how those massive holes are made? The process is far more complex and fascinating than you might think. The answer: the tunnel boring machine, or TBM, a giant mechanical earthworm, deep underground. These machines are marvels of modern engineering. At the front, a massive rotating cutter head chews through rock and soil, inching forward like a colossal caterpillar. This cutter head is equipped with numerous cutting discs and tools. But it's not just digging. Inside, conveyors carry out the excavated muck, efficiently removing tons of material every day, while robotic arms install precast concrete segments to form the tunnel's permanent lining. This ensures the tunnel is stable and safe for future use. In one continuous motion, the TBM excavates, removes debris, and builds the tunnel, all at once. This seamless operation is a testament to human ingenuity. These machines can be several stories high and longer than a football field. Their sheer size and power are awe-inspiring. They're the unsung heroes of modern infrastructure, working in the dark so we can travel in the light. Without them, many of our daily commutes would be impossible. Instead of leaving a dangerous, unstable hole, TBMs create strong, waterproof tunnels as they go. This makes them indispensable for urban development. It's a slow-motion ballet of brute force and precision engineering. Every movement is calculated and executed with care. TBMs take on immense earth pressure and stubborn rock, building the arteries of our modern world. They pave the way for new transportation routes and utilities. Next time you drive through a tunnel, remember the Leviathan that made it possible. These machines are true giants of engineering. For decades, countries like Germany and Japan were the undisputed leaders in the tunnel boring machine, or TBM, market. Their machines set the global standard for reliability and engineering excellence, and their logos became synonymous with cutting-edge tunneling technology. During this era, China depended heavily on expensive imports, bringing in foreign TBMs to power its early infrastructure projects. But as China embarked on an unprecedented infrastructure boom, the demand for tunnels, and the machines to build them, skyrocketed. No other country needed as many TBMs, or as quickly, as China did. Faced with soaring costs and long wait times, China decided to take matters into its own hands. Engineers began reverse engineering imported machines, carefully studying every component and process, and then building their own versions. In 2009, the first domestically developed TBM rolled out of a Chinese factory, a true turning point for the nation's industry, and a symbol of growing self-reliance. But Chinese engineers didn't stop at copying. They pushed the boundaries, making TBMs bigger, smarter, and more powerful than ever before, introducing new features and advanced automation. By 2023, China was not just keeping up, it was building the world's largest TBM main bearing, a feat that marked its break from foreign dependence and showcased its engineering prowess. Today, China supplies nearly 70% of the world's TBMs, with a fleet of around 5,000 machines, an industrial scale unmatched by any other nation. Once an importer, China now exports TBMs to every corner of the globe, even to high-profile projects in the European Union, where it once bought its first machines. It's a stunning leap from customer to global leader in just 2 decades, transforming the global TBM industry and shifting the balance of power. Chinese TBMs are now shaping tunnels from Paris to Kuala Lumpur, helping build the infrastructure of tomorrow in cities around the world. This is technological independence on a global scale, achieved through relentless effort and vision. China's rise in TBMs is a story of speed, scale, and relentless innovation, proof that with determination and ambition, a nation can transform its place in the world. Calling a TBM big is an understatement. These are mobile industrial complexes, each one a marvel of modern engineering. A large TBM's cutter head can be over 15 meters wide, as tall as a 5-story building tipped on its side. Imagine the sheer scale of that. Weighing over 4,000 tons, that's like 650 elephants packed into a steel tube. The logistics of moving such a behemoth are staggering. The cutter head's power rivals several Formula One cars running at full throttle, cutting through rock with ease. Each TBM is a symphony of over 20,000 components: hydraulics, electrics, ventilation, and guidance systems all working in harmony. It's a masterpiece of coordination. The latest Chinese TBMs, like Linghang, are even more advanced, intelligent, automated, and packed with sensors. They represent the cutting edge of tunneling technology. They monitor everything in real time, from cutting disc wear to rock conditions ahead, ensuring optimal performance. These machines can predict problems, adjust automatically, and even be operated remotely, reducing the need for human intervention. Fewer people are needed at the dangerous front line, making tunneling safer and more efficient. TBMs are not just big, they're smart, adaptable, and essential for modern megaprojects. They are the backbone of our underground infrastructure. They're the ultimate blend of brute force and high-tech precision, a testament to human ingenuity. The future of tunneling is here, and it's massive, intelligent, and incredibly efficient. Before exporting TBMs, China had to prove them at home, against some of the world's toughest geology. The Tian Shan Shengli Tunnel, completed in 2025, is the world's longest expressway tunnel, 22 kilometers through the formidable Tian Shan Mountains. Engineers faced hard fractured rock, extreme cold, and constant risk of rock bursts. Custom-built TBMs conquered these conditions, showcasing Chinese engineering and planning. Across China, TBMs have burrowed under rivers, through karst mountains, and beneath crowded cities, building up unmatched expertise. These projects turn Chinese TBMs into battle-hardened veterans, ready for any challenge. Malaysia's Titiwangsa Mountains are a formidable barrier for engineers. Tunneling is the only way to connect east and west. The geology is unpredictable: hard rock 1 minute, soft clay the next, and treacherous karst limestone riddled with hidden caves and rivers. Tunneling here is like drilling through Swiss cheese, never knowing when you'll hit a void. TBMs must be powerful and versatile, able to adapt on the fly to changing ground conditions. Cutterheads can clog, machines can lose steering, and water can flood in at any moment. Every meter of progress is hard-won, requiring robust engineering and constant vigilance. Malaysia's mountains may not be the tallest, but they're among the trickiest for tunnel builders. Here, nature tests even the most advanced technology. Malaysia turned to China for its toughest tunneling jobs, starting in 2012 with the first Chinese TBM export to Kuala Lumpur. That machine excelled, setting records for metro construction and proving Chinese TBMs could handle Malaysia's complex geology. This early success paved the way for deeper collaboration. The East Coast Rail Link, ECRL, demanded a fleet of powerful TBMs to cross the Titiwangsa Mountains. Chinese companies supplied not just machines, but expertise, operating and adapting TBMs to Malaysia's unique challenges. Each TBM is a technological ambassador, a symbol of China's engineering rise. Their performance in Malaysia is a global test of reputation. These steel dragons are taming terrain, once thought impassable. The world is watching, and so far the results are impressive. The battle between human ingenuity and nature is on full display in Malaysia's mountains. Mountains are ancient, unpredictable, and stubborn, posing hard rock, collapses, and hidden water to every tunneling attempt. TBMs are our champions, relentless, precise, and equipped with sensors to read the mountain's secrets in real time. Unlike old drill and blast methods, TBMs carve with surgical precision, adapting as they go. Every meter gained is a victory for engineering, but the mountain always has surprises. Sudden rock changes can halt progress for weeks, demanding repairs in cramped, dangerous conditions. It's a slow, grinding war of attrition, technology and persistence versus the Earth's raw power. In Malaysia, Chinese TBMs and ancient geology are locked in a high-stakes contest. Each breakthrough is a testament to human ambition, and a reminder of nature's enduring challenge. The ultimate showdown continues, deep underground. The East Coast Rail Link, ECRL, is Malaysia's most ambitious rail project, connecting east and west through the Titiwangsa Mountains. The centerpiece, the 16.39-kilometer Genting Tunnel, Southeast Asia's longest rail tunnel. Chinese TBMs, custom-built for Malaysia's geology, are tackling hard granite and complex formations. Advanced systems manage high-pressure rock and water ingress, guiding the machines with pinpoint accuracy. A tiny error at the start could mean disaster at the finish. Precision is everything. Each tunnel breakthrough is a celebrated milestone, proof of technology's triumph over terrain. But ECRL is more than machines. It's about collaboration and knowledge transfer. Malaysian and Chinese engineers work side by side, training local workers in high-tech tunneling. The project builds not just a railway, but national expertise and capacity. ECRL is a catalyst for development, uniting technology, people, and ambition. It's a modern marvel in the making. As TBMs chew through ancient mountains, we ask, can technology conquer nature? Modern TBMs build tunnels longer, deeper, and faster than ever, adapting to challenges once thought impossible. But nature always has surprises, hidden caverns, unexpected water, and chaotic geology. The Earth's complexity has evolved over millions of years. We're still learning its secrets. The future of tunneling is a race, smarter, more autonomous machines versus ever trickier terrain. AI and new tech will help, but nature will always set the rules. The TBM story isn't about winning or losing. It's a dance between ambition and the planet. Our greatest success is not just in conquering mountains, but in respecting their power. The job is never truly done. In the end, it's about partnership, technology and nature, shaping the world together.